Alrighty then, so I'm putting the finishing touches on this, and interestingly enough, I'm getting ready to put the number boards on, and I already did a couple. Let's see if we can see them here. Right, so there's a number board here, there's a number board there, right? So I put those on already. We've got some on the front of the engine, so right here on the front of the situation is that I've got one more left, which is up here. Now this is a Southern Pacific engine, and I've done some research to find out this can be the number of the passenger train rather than the engine itself. So the engine would have this number and this would have a different number. So the customer says 110 would be the passenger train that this particular one is. Didn't ask him whether or not he wanted me to change it or not. If I was going to change it, right, I would put a number in it. And so the way I do this is, you can see down on the, zoom in down here, and you can see, right, that I have printed the number out in different size fonts. So the different number 10, number 9, you can see the 9 and the 10 there. And then I actually did it all the way down, right, to like number 2 font. Right, white letters on black background. So you can figure out which size you want. You kind of start off just cutting off a portion of it like this, right? And then kind of fitting it down, looking and seeing where you are with it. As you can see here, that's not too bad, right? 2355 is not too bad right there, right? And I think that's probably the font that I used, right? But I had to cut off both the top and the bottom of this in order to get it to fit in the hole. Notice it's much bigger than the other one. And I'm using a piece of sticky tab, the 3M stuff I've been talking about, right? This adhesive putty, removable adhesive putty. It's useful in lots of different situations, and this is one of them, right, where I'm taking a toothpick and I'm just putting just a little dab of it on there because it's removable and it sticks to paper very well. This is just paper, okay, just paper, and I just used my inkjet printer to print it out, right? And I'm going to apply it on here, but before I do that, I want to go ahead and put a little drop of Tester's Clear Parts Cement, right, in it. So I'm going to do that. All right, if it'll come on out of their tube. Check to make sure I don't have the cap on. Ah, it was working just a couple of seconds ago. Oh my goodness. Oh. Hold on. All right, there we go. Okay, so now we're just going to put just a drop of it right here, right, across the number board, like that. And then we're going to take the paper number board, right? I'm just going to place it on there, and you get plenty of time to fix it because it's just glue, right? That glue is going to take, depending upon whether or not you use a hairdryer or not, right? May take a few minutes to set up, but boy, look at that, right? Just like that, and you got a number board. Huh? Yeah? Okay, I'm going to do the one on the other side, and then I'm going to come back. But this one here on the front, right there, right, has been sitting there already, and it's already dried, and I'm going to go over it one more time with this glue. Just going to get a drop, just the tiniest drop. And I'm going to take a toothpick and I'm going to smear it, kind of. I'm going to smear it across the face of that. I don't know if you can see this or not. Smear it across the face of it. I'm going to let it dry. And you know what that's going to look like when it's done? Oh. I can't wait. I can't wait. You're right, it's going to look like glass. It's going to have a glass outside to it. Huh? Look at that. Oh my goodness. All right. And the finished number board is just going to be absolute. It's just going to pop. Look at that. It's got glass on the outside. And it's just paper. Don't tell anybody. Okay, we're going to do the same thing with the one up here. And again, when you see this, it's just going to be tremendous when you see it with the what looks like glass across it. Okay, we'll let that dry just a few minutes, and we'll come back and I'll show you the end results of this. But again, a little technique, and again, that's what we're all about, right? All right, so while we're at it, we need to talk about another little trick. I learned this when I was building paper buildings. So this is not my trick, but somebody else's. If the white shows around the edges on this paper, so one of the things you can do is take a magic marker or a crayon. So there's different capabilities here. Let's see, I had a crayon here somewhere. Yeah, you can use a pastel color crayon, right? Black in this case, right? Or you can use a chalk, right? Black chalk. Either one of these three will work. I was using the magic marker here just a few minutes ago. This one may not be broad enough for it. I was using a big broad one. But I'm going to just paint the edge black, right, with the magic marker. I don't know if you can see this or not. But, whoop! I dropped it. Dropped it. Okay, there it is. Okay. Painting the edge with the magic marker. I'm having a hard time doing this while I'm talking. Anyways, you get the idea. Paint the edge with a black magic marker, or again with a crayon may be easier to do. But the paper is kind of delicate. So the magic marker goes through and creates a black mark on there. So then you don't see the white edges, and it may not seem like a big deal, but when you get it on there and you see white edges around it, you go, no, that doesn't look like I want it to look. It's so small, but little things count here. Okay, so the only wiring really left to do is the headlight, and so I've got these two wires coming from the piece that plugs into the tender and into the decoder, and I know that the one on the right, this one, is the red, or in this case blue, plus lead. Blue is the NMRA standard for the plus common for all functions. So I know that this one is the blue, and I know this one that's coming in is the negative or white wire, NMRA standard, for the lights. Now I could, the wires that are coming out of here are green and red, right? And those green and red stand for, in this particular case, that's not always the case, but red is, and I've tested this, red is positive, right, which would go to the positive blue wire, and then green is negative, which would go to the white wire. But once I get the shell on here, right, and if I went ahead and soldered these, then when you take the shell off, you'd have to unsolder in order to split the two. And so I elected to, and I talked this over with the customer, that what we need to do is put a connector in here, and this is the last thing that I need to do for wiring. But the connector that I'm going to put in there, I'm going to use a white black. Now I could use the red black or whatever. I'm electing to put the non-active, so the active or exposed, right, connector, right, or the two pins. I'm electing to put the socket on the active, which goes to the decoder, and I'm going to put it down here where when it's disconnected, right, you can't short this out. In other words, you might even be able to run the engine without the top on it. And you don't have the exposed leads where you could short out the decoder or that output, function output. Now I'm going to put it on top of this motor, and you'll see in a minute how I'm going to wire this, but I'm going to put it on top of this motor, and I'm going to go ahead and tape it down, and I'm going to use Captain tape, It's Kapton, right? And again, if you followed me on this, or if you followed anybody, right, who does this for a living, Kapton tape is essential for doing decoding because of its properties. It sticks to metal, which is really great. That's its designated place in life, and it's a very dielectric constant. In other words, its capability to insulate is very high, right? Used in the electronics industry to insulate things as it goes through a solder bath, and so again, temperature-wise, it's extremely high. And I'm going to trim off any excess here. I'm going to trim it right to the edge. Do the same thing on the other side. The blue that's here is decorative, but again, we don't need it to cloud it with a bunch of extra tape. And what I'm going to do now is I'm going to kind of relieve the wires a little bit, and then I'm going to use the white wire, right, to what would ordinarily be white all the way back. So these two would be consistent, and I'm going to pull them like this to wire it. Now I'm going to do that so that it stays out of the wire, stays out of the running gear here. So this is all moving in normal operation, and this flywheel that's on the back, because I don't want it to be in with the flywheel. So I'm going to put these two together right here, right where the Kapton tape is, and I may even release the Kapton tape and put the joint under there after I've soldered it, and right after I've put shrink tube over it. So we'll work on that in just a minute. And actually, I'm going to go ahead and do the other one while I'm at it, while I'm off. But the wires are coming through here. I'm going to make this such that this connector, this little 2-pin connector, connects to these wires back here somewhere, and we're going to tape them to the top of the boiler, right? So it can't move, but there should be enough play in it, right? So that it comes down. This comes down towards that plug, so I can plug it in right before I put the top in. And I actually kind of want it to splay backwards this way. So what I may do is I may turn this around a little bit, but I don't want it to be in the running gear again here in the flywheel. But I'm going to try to maintain these connections, all of these connections right here in this vicinity of the motor, where I know it's out of this universal and out of the flywheel. And I'll be back when it's ready to plug in. Okay, so what you see here is the finished wiring for the engine, minus, of course, this goes to the headlight, which I still have to do that. But for the most part, what I want to share with you is the fact that notice that the wires, all 3 wires on this side, 3 wires on this side, are outside of the running gear, and I'm talking about this, and I'm also talking about this back in here, and that when we finally get the light hooked up, that it will plug in the back like this, and on the top, right, it will be snug across the top like this, and again staying out of the running gear. So you don't get any real style points for making this look pretty here, although I've done a pretty good job, I think. I could do better, but did a pretty good job of encasing and keeping the wiring in order. Colors, again, coordinated. The white goes to the white or the negative side of the LED, and the black goes to the plus side. And you'll see that when I do this, I'm going to be very careful that I don't leave lots and lots and lots of wire in here. So I'm probably going to end up cutting this wire back and cutting this wire back to where this just barely plugs in here. And so that's the next step in this long but really very satisfying when we get it all fixed and ready to go project here. So be back when I get that done. Okay, so we're coming towards the end of this, and we need to be able to connect the black wire. So that's the last wire on this to ground here. There's no sense doing it to this hole because there's no screw that goes in the hole, but there is a screw that goes in this hole at this end and one at this end. And this one being the closest one, we're going to fish all this stuff in there, and then this is going to kind of hang out. And so what I want to do is I want to put a tab on the end of that. I want to put like a little round thing and tab this and then solder to it. I could solder directly to the chassis, but I don't want to put another restriction here. I want to be able to take this decoder out if I have to. So I'm going to put a tab there. Well, I don't have any of those little tabs, but I do have a sheet of brass. So I'm going to take this thin sheet of brass and I'm actually going to make a little collar that goes on there, and then I'm going to solder to it. So be right back with that. Okay, not really gorgeous, but very functional, and so this will tie into this screw right there when we put it together. But for the moment, we want to test this thing out. So we're going to plug this up and this up, and we're just going to, because there's no wheels on it, I'm going to tie this lug then to the left rail, and so we can test it. So over to the test bed. Alrighty then, with our test setup here, we've got the black wire hooked to the left rail, and we got some wheels here on the engine so it doesn't run away. We're going to go ahead and test to see whether or not the decoder is still working here. We're going to do program PG address 2. We're going to display. It comes back 03, which tells me that it's talking to the decoder and that everything is working well there. We're going to go ahead and test for address 4. So display that. At this point we still have nothing there. We're going to put in 2355. And we're going to go ahead and address 2355 on this engine. It came back as that. We're going to actually come back and display. We're going to ask the machine to check on that. Just test it out. Make sure it's right. It's testing, 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 and eventually here it should come back with the address. There it is, 2355. So we're in good shape. We're going to go ahead and get out of this and go back to our engine. I'm going to select the 2355 number here. Give me a second. 2355. Enter. I'm going to make sure the track is on. Okay. And we've got another engine on the track up there making noise, but we're interested in this engine, so let's turn it on here. Oh, we got something. Bell, I hear bell. Okay, let's see if we got some lights. That's important. Looks like it's going forward. Check the lights out. Holy cow! All right. Yes, we're up on the lights in the front. Perfect. And lights in the rear when we hit reverse. Yes. Okay. The only other thing left is the motor. Let's see if that motor runs. Whoops. Well, we got something stopped. All right. Let's find out what's on. Alrighty then, so with all of that and testing and everything looked really great, and then oh no, crosshead again, piston is separated. Wow, all of this work, and if that's not fixed, well, the whole job is scrapped. So I'm going to try to fix this one more time. I've tried soldering, I've tried super glue, I've tried riveting. I'm going to try a bracket, and the bracket's going to kind of go like this around the piston from the back, and let's see if we can fashion a bracket on there and solder that in place to keep this together. The other thing that I noticed too while we're at it here is the crosshead kind of goes back and forth like this. Okay, so let's get a closer look at this. See, the crosshead goes back and forth. Focus. Goes back and forth like this. So that means that the rails are not quite parallel. So, you know, if it was better fixed, the other side looks pretty good. The other side doesn't do that, and it might be because of the piston as well in there. But I'm thinking if I can get these two rods closer together, and I could just pinch them with, they're held together with this bracket back here in the back. And the bottom and top, and so actually that should slide fine without that. Now maybe the nut is too tight. I don't know, but whatever, it's creating a problem, because even without the piston rod being attached, this should work just fine. It should go back and forth and not bind, but it's binding because it gets gollywampus. Is that a word? It gets skewed in the track, and then gets bound up. So I think I need to see if I hold it there with my thumb like that. It seems to be pretty tight. So I'm going to move this bottom rail. I'm going to try to twist that up and see if we can fix that. I'm also going to create that other thing. Notice it on the cylinder. On the piston head there's a looks like an hourglass type thing, but there's a ledge right here that I can I'm thinking about putting around. You'll see when I manufacture the piece that I need. I'm going to use spring steel. Actually, I'm going to use a KD coupler spring, believe it or not the old style box spring. So I've got a piece of metal that I can fashion on that. Again, you'll see that in a second. Okay, so this is what I'm talking about. I'm going to use that to fashion the spring with. All right, so here we go. All right, so after taking a few careful dimensions and trying to CAD this thing, and let's see if I can zoom in on the parts here. Well, everything's going to move on me. So what you see here is the bracket. I don't know what you call this that I'm trying to make here. This is made out of a KD coupler spring, pocket spring, and then carved or filed some pinches in it, and this will actually go. Get a pair of tweezers here. It'll actually end up going like this across the crosshead, and then this piece in here, right? You get the idea. So that this will actually pin these two pieces together. That's the objective. This is upside down from where it would ordinarily be, but kind of like this. Ends up going across there. So that's the thought. And then I'm going to try to solder and glue all that together. Again, this crosshead has got to be stable in the bracket and with the piston rod. So after all of that, I looked at the other side and I said, you know, there has to be a way that this is put on there that's better. And if I looked at the numbers here, the 0.026 is the length of the nib that's sticking out, and 0.015 is the thickness of the place where it goes in. So I said, you know, that had to be riveted in there. It had to be riveted in there somehow. So I tried different tools, like I tried, you know, a screwdriver, and that wasn't good enough. And I decided I was going to use a drill. So use a hardened drill and put it in this little stand here. So I don't know if you can see this, but I put a hole that goes all the way through, and it's just the right size for the piston rod. So I stood it up, and then I hit it, and actually it's in there. So I'm going to abandon my other shot. It appears as though this is going to stay with it bent over and riveted. I don't know if it's hard for you to see that, but it turns in this, and then you can see that, but it still is attached. So I might give it another couple whacks, but it appears like that's the ticket, rather than try to manufacture anything else. I may even still glue and try to solder it, but I'm going to give it another peen, and then we're going to put it back together again. Alrighty then, it's all put back together again, and here's the run. Let's change we got a nice headlight, and you can change the brightness of the headlight through the CVs. I haven't worked on the chuff rate, but it's not too bad. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. So it's a little fast. But the system and everything else is working. It's doing pretty good. Let's go back. Oh yeah. So I'm running out of battery here, so I'm going to have to shut it down, but there you go. Finally. And the crosshead's working well, and the piston's staying in place. Super good. All right. Bell, whistle. Bell needs a little bit more, but good shape. All right then.